Good day, everyone. I'm Arvin Enriquez, your subject teacher. So, with this video lesson, we're going to discuss functions under your general mathematics from quarter 1, module 1. Our lesson objectives. At the end of this video lesson, you are expected to recall the concepts of relations and functions. Define and explain functional relationship as a mathematical model of situation, and represent real-life situations using functions including piecewise function. So let's go now with the formal definition of a relation and a function. For a relation, when we say relation, is any set of ordered pairs. So meaning to say if there's a set of ordered pairs, so there's an involvement of your x and y values. The set of all first elements of the ordered pair is called the domain. So dealing with your domain, this will be your x values in a given set of ordered pairs. So that will be your first elements from the relation. And the set of all second elements is called the range. So that will be your y values in the given set of ordered pairs. Now, dealing with your relations, no, how can we assess if the given set of ordered pairs is a relation? First thing to do is to look what is the relationship or what is the existing relationship between your x and y variables. If the existing relationship between your x and y variable is many to 1, so many values of x can provide you only one value of y, and it can be 1 to many, or one value of x can provide you many values of y, and or one-to-one relationship between your x and y variable. So one value of x can be mapped or can provide you, only one value of y. So that will be your relation. Your relation again can be many to one, one to many, or or one to one relation. Now let's go now with your function. So a formal definition of a function is a relation or a rule of correspondence between two elements. So your domain and range. Again, there's an involvement of your domain and range. So that will be your x and y values, that you can see on the given set of ordered pairs. So such that each element in the domain corresponds to exactly one element in the range. So you need to take note of this. Once you are dealing with your function, the domain of the corresponds to exactly one element in the range. So meaning to say, if there is a given set of ordered pairs, as long that there is no repetition in your domain or x values, then the given set of ordered pairs is a function. Now, if we try to assess a given set of ordered pairs, if the relationship exists between your x and y variable or x and y values in the given set of ordered pair is many to one or one to one relationship, then the given set of ordered pairs is a function. Again, as long that there is no repetition in your x values under your set of ordered pairs, then the given set of ordered pair is a function. So in a simple word, all functions are relations, but not all relations are functions, because functions can be many to one to one, but not one to many. Because dealing with your function, no, again, there is no repetition of values in your x values or in your domain. So that will be your function. So let's now apply the definition of your function and relation. So with the given ordered pairs here, which relations are functions? So meaning to say these A, B, C, and D are considered as relations. But how can we check if these ordered pairs or the given set of ordered pairs here are also a function? First thing to do, for letter A, we need to check if there's a repetition in your x value. In your x, first x will be 1, second x is 2, your third x is 3, your fourth x value is 4. So if we try to observe your set of ordered pairs now under your A, there is no repetition in your x value. So meaning to say, your letter A is a function. For letter B, again, let's try to check if there is a repetition in your x values. For your first x value, that will be 3, second is 4, then your third is 5, and your fourth is 6. Again, there is no repetition in your x values. It's fine if there's a repetition in your y values. What we need to check is the repetitions of your x. If there's an existing repetition between your x values with the given set of ordered pairs. Now, for your letter B, no, as long that there is no repetition in your x value, this set of ordered pair is considered as a function because there is no repetition of value or values in your domain or x values. Now, for letter C, same thing to do. Let's check if there's an existing repetition uh, in your x value. For your first value of x, that will be 1. Your second is 0. Then your third is -1. And your fourth x value is 0. So meaning to say your second x value here and your fourth value are equal. So there's a repetition of your x value here. So meaning to say this set of ordered pair is a relation but not a function because this set of ordered pairs under your C, no, uh, represent at some point it represent a one to many relationship. Why? Because your 0 can be mapped to your +1 and to your -1. Meaning to say, one value of x, which is your 0, will be mapped to your two values of y that will be -1 and +1. Or a simple word, if we apply the value of your x, which is 0, to a function, no, it can provide you two values of y, which is +1 and -1. Meaning to say, your set of ordered pairs under your letter C is not a function. For the set of ordered pairs under your D, let's check. Again, the same process. You need to check if there's a repetition under or within your x values with a given set of ordered pair. So your first value of x is A, your second value is B, your third value is C, then your fourth value is A. So meaning to say, your first value here and your fourth value here are equal. So there's a repetition in your x values, meaning say the set of ordered pairs under your D is not a function. It's fine, no? It's fine if there's a repetition in your y values. Our concern here, how can we check if the set of ordered pairs, if the set of ordered pair represent a functions or not? So our concern here is only your x values. If there is no repetition in your x values, then the given set of ordered pair represent a function. If there is a repetition in your x values, then that will be a relation, but not a function. So for the next example, for us to understand well what is a function and a relation, how about using this given table of values? So which relation shows a functions? So your A, your B, and your C are considered as a relation. But again, which relation shows a function? So if we try to assess now the same process that we have done a while ago, no, we're going to check if there's an existing repetition in your x values. So if there is a repetition of x values under this table, then the given relation, no, does not show if or represent a function. For your letter A, no, your table under your letter A, so there is a given table here under your A. So there is a given values of x, which is 1, your 2, 3, 4, 5, and 6. So by simply looking at the values, no, under this table, so there is no repetition of x value, meaning to say that there is a one-to-one relationship between your x and y values here. Your y can we can map your 1 to 2, your 2 to 4, your 3 to 6, 4 to 8, 5 to 10, and 6 to 12. Even in your y values, there is no repetition of values, meaning to say that there is a one-to-one relationship between your x and y values under your table A. So meaning to say this table is a function. Now for letter B, so your first value of x, no, same process. We need to check if there is a repetition of values, x values under this table. So we need to check for letter x, for x value, I mean, your first value is 4, your second value is -3, your third value is 1, your fourth value is 2, your fifth value is 5. Now, as you can see on your range or y values, so there is a repetition of -2, -2, -2 that we can map on -3, +1, and +2, I mean. But this -2, -2, -2, uh, there is no varying, no? Once we decide if this table represents or shows a function. So what we need to check if the table, no, shows or represents a function by simply checking if there is a repetition between your x value. Again, if there is no repetition in your x value, it's automatic even if there is a repetition in your y values. As long that there is no repetition in your x values, then the given table now shows a function. Why? Because there is no repetition in your domain, or there is no repetition in your x values under this table. Now, let's go now with your table C. Same process. You need to check if there's a repetition in your x value. First value is 0, negative 1, 4, 2, and negative 1. Your second value and your fourth value, they are equal. They are both negative 1. So meaning to say, by simply looking at this value, we can decide if this relation shows a function or not by simply assessing if there is a repetition in your x value. Since there is a repetition in your x value under your table C, then this table is a relation but not a function. For the next example, so using these mapping diagrams from your A, your B, and C, so which do you think represent functions? So the same process, no, with a set of ordered pairs from the table, dealing with mapping diagram, it's the same process. We need to check if there's an existing repetition of values, no, or x values, I mean, no, or your values under your domain. So for letter A, here, your A uh, is mapped, no, to your X. Your B will be partnered to your Y, and your C is also partnered with your Y. So if we try to separate, no, each of the relationship, no, between your domain and range for letter A, so your A can provide you an X value. Your B can provide you a Y value. And your C can provide you a Y value. So this will be your domain and this will be your range. Now, again, since there is no repetition with your X value or your values under your domain, meaning to say your letter A represent a function because it represents a one-to-one relationship between your A and X and a many-to-one relationship in your B, C, and Y, no? Both your B and C can provide you a value of Y, no? Or your B and C are both mapped to your Y. So that will be a many-to-one. Again, a function can be a many-to-one or a one-to-one relationship between your X and Y variable. For letter C, I mean for letter B, no, for your mapping diagram under your letter B. So if we're going to dissect, no, these values under your domain. If this is your domain and this will be your range, your X will be partnered to your A. Your X will be partnered again to your B. Then your Y will be partner again. I mean your Y will be partnered to your C. So if we try to assess, no, your values in your domain, so there is a repetition of X value, which is your X, no, that can provide you two values of your Y, which is your range, which is A and B. So the relation between your X, A, and B, no, is a one-to-many. One value of X can provide you two values of Y. So that's a one-to-many relationship. Now, with even if there is a one-to-one relationship between your Y and C, but under your mapping diagram, there is an existing relationship which is one-to-many relationship between your X, A, and B, then your mapping diagram under your letter B is not a function because there is a repetition of X here. Now, going to your letter C, no, Jana was partnered to Ray. Donna was partnered to Mark. And Maya was partnered to Ken. So there is no repetition with your domain here, and there is no repetition in your range. So there is a one-to-one relationship between Jana and Ray, Donna and Mark, and Maya and Ken. So meaning to say, your letter C is a function, or this mapping diagram represent a function. So let's go now with the concept of your vertical line test. So the vertical line test, so a graph represents a function if and only if. So you need to take note of this. You need to take note this word, if and only if. If each vertical line intersects the graph at most once. So meaning to say, once we apply your vertical line, if there is only one point of intersection between your vertical line and your graph, then the graph represents a function. So if there are two or more point of intersections between your vertical line and a graph, no, so therefore your graph did not represent a function. So we simply use your vertical line test for us to determine, identify, no, if the given graphs represent a function or not. So let's go now with your letter A, no, for your graph, your letter A here. So there is a line here. So there is an X and Y axis, and there's a line intersecting your X and Y axis. But we're not after to your X and Y axis. So let's apply now with your vertical line test. So if we apply your vertical line test here, no, so as you can see, there is only one point of intersection here, no, between your graph, which is your line, and your vertical line that we apply. So meaning to say, your graph under your A is a function because there is only one point of intersection between your vertical line and your graph, which is a line also. No. Now, for letter B, is it a function or not? So let's apply again your vertical line. So once we apply your vertical line, no, any to this portion, no, any uh, portion with your graph, no, it can works with your vertical line test. So it can be here, it can be here, but I choose to be here. It depends on you, on how you apply your vertical line test. But again, no, if you decide that you're going to put your vertical line here and vertical line here, no, you need to satisfy the given condition if and only if, no, if each vertical line intersects the graph at most once in all parts of your graph. So you need to satisfy that once you apply your vertical line, because there are graphs, no, at some portion you can satisfy that condition, but at some portion of your graph you can you can't satisfy the given condition because at some point there are two or more point of intersection between your graph and your vertical line. Now, with this letter B, no, your graph under your letter B. So once we apply your vertical line test here, so there's a point of intersection here, one point of intersection, and there's another point of intersection here, which is your second point of intersection. So meaning to say that this graph did not represent a function. It's a relation, but not a function. For letter C, it's the same process. If this is a graph representing a function or not, the same process. We apply your vertical line. So it depends on you on how you apply or where you can apply or you want to apply your vertical line. No, so this portion. So I'm going to choose this portion and check if there is an existing intersection between your graph and your vertical line. So as we can see, there's a point of intersection here between your vertical line and your graph. So there is only one point of intersection between your graph and your vertical line. The same thing if we apply here, so there is only one point of intersection here. So meaning to say that this graph is a function. Now, going to your letter D, if this graph represents a function or not, the same process. We apply your vertical line test. So if we apply your vertical line test here, so there is a point of intersection here and another point of intersection here, between your vertical line and your graph. So meaning to say this graph is not a function. Because in this case, once there are two or more point of intersection, once we apply a vertical line test, meaning to say that one value of x can be mapped to more than two or more values of y. So that's a zero. I mean that's a one to many relationship, no, that represent a relation but not a function. So for another example, which of the following represent a function? So here there are four equations and we're asked to assess and to check if these equations are represent a function or not. For number one, y is equal to 2x plus 1. So if we try to go back with the concept of your geometry, your y is equal to mx plus b, wherein your m is your slope and your b is your y-intercept. So this will be your y-intercept form. Now, if we're asked to graph the given equation of a line, so what will be the orientation of the graph? So if your m is a positive value or your slope is a positive value, your line rises from left to right. If your m is a negative value or your slope is a negative value, then your line falls from left to right. So since here, your slope is a positive value, which is positive 2, then we adopt this graph that your line rises from left to right. So once we apply your vertical line here, your BL, that will be your vertical line. So there is only one point of intersection between your vertical line and your given line, which rises from left to right, because your slope is a positive value. Since there's only one point of intersection between your vertical line and your graph, then your number one represent a function. For number two, it's y is equal to x squared minus 2x plus 2. So this is a quadratic equation. So what are the figures or shape that represent a quadratic uh, function? So it can be circle, parabola, hyperbola, and ellipse. But again, by simply looking and by simply assessing the given variables in your equations, if your x squared exists in your given equation and your y squared does not exist in the given equation, then most probably and most of the time, this equation, if that is the case, this equation represents a parabola. Now, the question is that if this is a parabola, what will be the orientation of the opening of this parabola? So again, by simply rearranging your terms by variables, so we put all the variable x to another side and we put y to another side of your equation, and the constant, which is 2, by simply putting this positive 2 to another side of your equation, so that will be a negative 2. So since this is x squared and this is a positive value of y, if this is your y and x axis, your parabola opens upward if this is a positive y. Now, if this is a negative y, then your parabola opens downward. So in this case, your parabola opens upward. So if we apply your vertical line here, there is only one point of intersection between your vertical line and your parabola that opens upward. So meaning to say, number 2 represent a function. Number 3. So now for number 3, y is equal to square root of x plus 1. So there is a radical sign here, which is your square root sign. So by simply putting an assumed value of x, so we can identify if this one value of x can provide you two or more values of y. Let's say your x is equal to positive 3. So your y now is equal to square root of 3 plus 1, or simply your y now is equal to square root of 4. So that value of x can provide you two values of y, which is positive 2 and negative 2. So meaning to say, one value of x can provide you two values of y. So how can we graph this one? Your true 3, no, can be mapped to both positive 2 and negative 2. So our relationship between your domain and your range, no, which is your 3 and 2 and negative 2, is 1 to many. So meaning to say, this equation number 3 is a relation but not a function, because it represents a zero, a one to many relationship. One value of x can provide you two values of y. So meaning to say, there is a repetitions once we put this one in a uh, in an ordered paired way, or in a set of ordered pair. So there is an existing repetition of x value, which is 3, 2, and 3 and negative 2. For number 4, so since there is no radical sign here, there is no uh, square root I square, no exponent, which is 2, 3, 4, no, your highest exponent in this one is 1. So therefore, if we put a certain value of x, no, here, so there is only one value of y that can be mapped to one value of x, or one value of x can provide you only one value of y. So meaning to say, any value that we're going to put here as a value of x in the given equation can provide you only one value of y, because there is no radical sign, there is no exponent which is greater than 1. So therefore, we can assume, or we can say, no, that there is a one-to-one relationship between your x and y variable. Meaning say, this number 4 represent a function. So let's read some of the conversations and determine if they can be classified as functions or not. So for scenario number 1, so June and May are in long time relationship until June realized that he wants to marry May. So based on the conversation, no, when June said, "We're together for the last 7 years, and I believe you are my forever. Will you marry me? So there's a question here asking May, no, if she wants to marry June. And May replied, no, if I said yes, what could you promise me? So there is a question here that pertains, no, what if she said yes, what what can June can offer and promise to her? Then June replied, I promise to love you forever, to be faithful and loyal to you until my last breath. So there is a keyword here, until my last breath. So meaning to say up to the last second of his life. And May replied to this, I love you too, and I will marry you. So at the end of this story, of this scenario, May said yes, and he wants also to marry June. So meaning to say, if June um, will consider from time to time his promise, no, to May that he will be loyal and faithful until his last breath, they will be or in a conditions wherein they will last up to the last second of their life. So meaning to say, at the end of this story, if May decided to marry June, no, and June continued doing his promises, no, to May, then there is a one-to-one relationship between June and May. But if at some point, no, when June decided to enter a Muslim community, no, then he can marry two, three, four, or more girls as long that he can provide all the things uh, that can help, no, for these girls to survive, no, then it's fine to their religion. But again, there is no word here being mentioned that pertains to a Muslim community. So we assume that June and May is a Christian, wherein they will be together up to the last second of their life. So that will be a one-to-one relationship between June and May. When June asked May, and May replied yes, so that will be a one-to-one relationship. So for us to visualize more the scenario number one, so marriage is an example of functions when there is a faith and loyalty. So we always promote faith and loyalty uh, in all times, no, when you're dealing with marriage. And we're talking about marriage, we always promote faith and loyalty. So let's say June is the domain. So we let June as your domain and main is the range. When there is a faithfulness, no, in their marriage, there will be a one-to-one relationship. One domain to one range, or one husband to one wife. But if June tries to look for someone else, for example, he decided to go with the Muslim community, or he decided to go with the other girl, no, the relation is not a function anymore since June will have two wives. This will happen if June no, or enters the in the Muslim community. But if not, so there is a one-to-one relationship between the relationship of your between June and May. Second scenario. So Kim is naturally born Filipino, but because of her eyes, many people confuse if she is a Chinese. Let's see how she responds to her new classmates who are asking if she's a Chinese. Hey classmate, are you a Chinese? Then she replied, no classmate, I was born Filipino. Ha! Hey Kim, can you teach me some Chinese language? May I said that my veins run a pure Filipino blood. I love Chinese, but I'm sorry I can teach you because I'm a Filipino. I was born Filipino and will die as Filipino. Kim, I thought you are a Chinese because of your features. So if we're going to base no with the features of Kim, so there is no one-to-one relationship. But again, considering that Kim born here in the Philippines, no, and to be a naturally born Filipino, one consideration that we're looking if Kim was born here. So if not, there is a case that or there's a possibility that Kim is a Chinese, but Kim was born here, so we consider that Kim is a naturally born Filipino and a pure Filipino without considering or without dealing to her features. We cannot say that Kim is a Chinese because of his eyes. So the nationality of a person depends on where he or she was born. So since Kim was born here in the Philippines, then Kim is considered no as a naturally born Filipino. So for more of this Kim for the nationality, so nationality could also illustrate a function. We expect that at least one person has one nationality. Yes, it is, no? Let's say Kim is the domain and her nationality is the range. Therefore, there is a one-to-one relationship because Kim was born and live in the Philippines. She can never have multiple nationalities except Filipino because she was born and live in the Philippines. Therefore, between the nationality and aside then between Kim and her nationality, there is a one-to-one relationship. So for scenario number three, so as part of the requirements in statistics class, Andre made a survey on the religion of his classmates. And here's what he found out. Andre, good Andre said, good morning classmates, as our requirements in statistics, may I know your religion? This data will be part of my input in the survey that I am doing. Anna said, I am a Catholic. Kevin, I am also a Catholic. Sam, I am a member of the Iglesia ni Cristo. Joey, I am a born-again Christian. Lani said, my family is a Muslim. Jen said, we are sacred, a Catholic family. Andre uh, replied to his classmates, thank you classmates for your responses. So there is a multiple religion being mentioned on this conversation of Andre to his classmates, Anna, Kevin, Sam, Joey, Lani, and Jen. But again, is it a one-to-one relationship? So let's try to check. No, religion is also an example of a function because a person can never have two religions. Yes, it is, no? Because Andre can be a Catholic but not uh, an Iglesia ni Cristo at the same time. So there is a one-to-one relationship between a student and his or her religion. Inside the classroom, three classmates said that they are Catholic. This shows a many-to-one relationship. Classmates being the domain and religion I mean, being the range, indicate that different values of domain can have one value of range. So in this case, no, still it's a function. Why? Because if we assign the students, no, as a domain and the religion as the range, domain this will be your x and your religion that will be your y. So meaning to say the relationship between your x and y variable is many to one, many student to one religion, and that's a Catholic. Wherein Anna, Kevin, and Jen, they are all Roman Catholic. So therefore, it's a many to one relationship. Still, it's a function. So your scenario number three represent a function. Even if there are multiple religions being mentioned on this scenario, what we're trying to assess is that if there is an existing repetition of names of student, no, in your domain. So if not, it's fine. Even if there is a repetition of religion that we can map on each of the student included in this survey. But in this case, no, there is no repetition in the student's name, and that is the consideration that we need to deal with. Even if there is a repetition in the religion, since there is no repetition in the student's name, then your x and y variable or your domain range represent a many to one relationship. Many student to one religion. So let's deal now with the functions as representations of real life situations. So functions can often be used to model real life situations because we simply use one function or two more functions to represent a scenario, a condition, or for example, growth of a living organisms. So we simply use functions to represent how these living organisms develop. Identifying an appropriate functional model will lead to a better understanding of various phenomena. Yes, no, it is no. Using your function and identifying the appropriate functional model, it really helps us no to understand what are the various phenomena, what are the variation. So what are the conditions no that we need to satisfy to see the flow no of these phenomena of this growth of a living organism. So we just simply visualize these thing no or things no by simply dealing or by simply identifying the appropriate functional model. So that will be if the real life applications of these functions. So let's deal with example number one. So give a function c that can represent the cost of buying X meals if one meal costs 40 pesos. So we're asked to find no the function no using this function c no that will represent the cost of buying X meal. If one meal costs 40 pesos, meaning to say we just simply use this one, no? Then the cost function cx. So we use c and your x your C as a function that represents the cost of buying with respect to X, this will serve as the number of meals. What if we buy 2 meals? What if we buy 3 meals? No? So that will be equal to 40 pesos multiplied by X. So X is the number of meal and 40 is the price per meal. So if we buy 2 meals, so we just simply multiply 40 by 2, so that will be the total cost of buying 2 meals. So that will be 80. Same thing up to that, when your x increases, it's automatic that the value of function c also increases because it multiplies, no, the cost of each meal that we are dealing with. If that is 40, it depends on the number and we multiply it to 40. So that will be the value now of the function c that can represent, or that will represent, no, the cost of buying an x meals. So for example number 2, so 100 meters of fencing is available to enclose a rectangular area next to a river. So we're asked to give a function of a that can represent the area that can be enclosed in terms of x. So we're looking with the value of y, no, in terms of x, because we're asked to find the value of a function a in terms of x. So there is no such thing that there is a y, no, variable in our final answer, because we're asked to find the value of function of a in terms of x only. So we should look for the value of y in terms of x. Now, dealing with your geometry, no, again, we just simply apply the concept of the area of a rectangle, which is x, y, or simply that will be your length multiplied by width. Supposed to be, if in dealing with this formula, no, so there is a length here, which is your x also, that is parallel to another side, no? So we will write this as a function of x. Now, since there is a given value of fencing, no, available, no, the length of a fencing was given, no, in this problem. So we assume that this 100 meters is a parameter of the enclosure rectangular area here. So this will be your 100 meters. So this will be your 100 meters here. So as you can see, this will be your 100 meters. For us, for us to visualize more, no? So this will be 100 meters. So I mean to say, if there's a y here, and x here, and y there, so your 100 meters now is equal to 100 meters is equal to your y plus your y plus x. So in this side, no, as you can see in this side, there's no enclosure here. So this will be an open area. So open area. So your OA here is not overreaction, no? It's an open area here. So there is no fencing in this side. So we simply use this 100 meters here in this side. So 100 is equal to y plus x. Or we can say that x plus 2y is equal to 100. So we simplify this one. And we arrive with x plus 2y is equal to 100. If we simplify this y, this equation, no, this equation, we're going to simplify this one using this equation because we're asked to find the value of a, no, function of a in terms of x. So we need to get the value of y in terms of x. So what will be the value of y in terms of x? So that will be equal to 100 minus x over 2. So we just simply transfer this positive x to another side, that will be negative x. Then from multiplication to your 2y here, going to another side of your equation, from multiplication to division, that's why, that will be the reason why we divide your 100 minus x by 2, because we transfer 2 from your 2y in this equation. So if we simplify, so 100 divided 2, that will be 50. Negative x divided by 2, that will be 0.5. Once we apply, so your y now is equal to 50 minus 0.5x. So here we apply, so we're going to apply your a of x now, applying the concept of this area. So ax now is equal to x, which is your x here. Then your y, what will be your y now? Your y now is equal to this one. So that will be equal to 50 minus 0.5x square. I mean x. 0.5x, no? So we're going to erase this one. So it's x multiplied by 50 minus 0.5x. So upon simplifying, so this will be the final answer. So that will be your final answer. So this will be your final answer. So 50x minus 0.5x first, because we're going to distribute this x to 50 and x to 0.5x. So that will be 50x minus 0.5x squared. So that will be your final answer. So let's deal now with the piecewise function. So some situations can only be described by more than one formula, depending on the value of the independent variable. So our decision will be dependent, or our decision, if we're going to deal with one or more formula to describe the given situation, it will be dependent to the independent variable being given on the given conditions or situations. For us to visualize more, we're going to use this piecewise function um, in this example number 1, and we're going to use more than one formula for us to represent a fixed value that will be our independent variable. And what if we go beyond that fixed value? What will be the formula that we can use, or function that we can use to describe these given conditions? So for example number 1, a user is charged 300 pesos monthly. So that will be a fixed value for his or her mobile plan. So whether he use it or not, whether he he use the features of this mobile plan, he will pay the telecom communication, for example, Smart, Globe, Sun Cellular, 300 pesos monthly, even if without using this mobile plan. It's a fixed value, no? Whether you use it or not, you're going to pay them with the 300 pesos monthly because you apply for a mobile plan. So which includes, so there's inclusion in this mobile plan, which is 100 pre-text messages. Now, the next statement is that what will be the function that will represent if the messages in excess of 100. What if we go beyond to that 100 text messages, pre-text messages, So there's a rate here, 1 pesos for each of the additional text messages. So if that is 101 text messages, or after a month, we're done dealing with these text messages, then the total text messages that we sent, is 105. Meaning to say, there is an additional of 5 pesos to our monthly payment because 1 pesos will be applied to the excess text messages. No. So we're asked to represent the amount of consumer fees each month as a function of the number of messages M. So we use letter M to represent the number of messages sent in a month. So for our solution, we simply use TM. That will be the function that will represent the amount paid by the consumer each month. It can be expressed by the piecewise function. So this will be the concept of piecewise function. So here in your upper part of this piecewise function, so there is a fixed value which is 300. So that will be the amount of which is payable, no, for your mobile phone. That will be a fixed value for your mobile phone, no, which is 300 pesos if we satisfy this condition. If the number of messages falls, no, from 0 to 100 and a maximum of 100 text messages per month, then you're going to pay a fixed uh, char charges, no, which is 300 monthly for your mobile plan. So if a user, no, just only use 90 of these 100 pre-text messages, then still 90 falls from 0 to 100. So it falls from 0 or in between your 0 and 100. Meaning to say, the user will pay, no, three, still 300 pesos for his monthly mobile plan because there is no excess, no, with his text messages. So it falls within from 0 to 100 and can be maximum to up to 100 text messages because that's one of the inclusions in his or her mobile plan. Now, what if the user go beyond to his or her pre-text messages? What if he use, no, 200, 300 text messages a month? So what will be the function that will represent now if there's an excess to his or her pre-text messages using his or her plan, mobile plan? So we simply use 300 plus M because M will represent the number, no? The number of messages, no? M is the number of messages. So for example, if the user used 150, so there's an excess of 50 there, no? Because 100, there's only 100 pre-text messages, no? So there's a 50 pesos additional to his charge. That's how we apply, no? That will be 300 plus M now. If M is greater than 100. We only use this piecewise function, no, if we satisfy this condition. If your text messages is greater than 100, that's that's the time that we're going to apply this 1 pesos, I mean, for each of the excess text messages from the 100 pre-text messages. A jeepney ride costs 8 pesos for the first 4 kilometers. So there's a fixed value here, which is 8 pesos only for first 4 kilometers. And each additional integer kilometer adds 150 pesos, 1 and 50 centavos to the fare. No. Use a piecewise function to represent the jeepney fare in terms of the distance d in kilometers. So in every additional kilometers, no, for example, if that is 5, no, 5 kilometers, so your cost, no, of travel is 950 pesos. Then, what will be up to, for example, if you travel 6 kilometers, what will be the cost? So in this scenario, or for in this example problem, no. So what will be the piecewise function that will represent that, no? So what will be the function that we can map on this type of scenario? So for our solutions, the input value is the distance and the output is the cost of jeepney fare. If fd represent the fare, no, as a function of distance, the function can be represented as follows. So fd, or your fare now, is 8 pesos if we satisfy this condition. 8 is a fixed value. If we satisfy this condition, that 0 is less than d, or less than or equal to 4, then because there is a fixed value here, which is 8 for only for the first 4 kilometers, no? So the value of d should fall, no, between your 0 and 4. The maximum value is 4, or it can fall in between your 0 and 4. If d falls, no, in between your 0 and 4, or it falls exactly to 4, then the fare is equal to 8 pesos, because 8 pesos is a fixed value only for the first 4 kilometers. Now, what will be the fare, no, or jeepney fare, if we if the kilometers, no, that we traveled is more than 4? So as you can see here, no, the symbol here, which is your d, denotes the greatest integer, or the floor function applied to d. So the floor function gives what? So the largest integer less than or equal to d. Example, 4.1. So if we apply this floor function to 4.1, so that will be equal to 4.9 or equal to 4. So we just simply apply these floor functions, no, and these symbols if your d now is greater than 4. Since we have a fixed value of fare here, which is 8 pesos for only for the first 4 kilometers, so these functions here, 8 plus 1.5 multiplied by floor function of d, is a function that will represent if there is an excess, or if we go beyond your 4 kilometers. If we travel for example, 6 kilometers, no, then we apply this value, we multiply it to 1.5. Since there's a given value here, 1.5, to every additional kilometer that we travel. So if we travel 8 kilometers, so there's an additional 4 kilometers, so we multiply 1.5 by 4 plus your fixed value here, which is 8, no? So that will be equal to 14. So we need to satisfy this condition if and only if your d is greater than 4, or the distance that we travel is greater than 4. So for your activity at home or in your community, look for at least 3 situations that could represent functions. From the identified situations, write a sample problem and its corresponding function equation. So here there is an example of this activity. You just simply use this as your guide in making your, or in dealing with your activity. You just simply write situations here, situations, then a problem, and identify what will be the function that will represent, no, or what will be the answer of for that problem. What will be the function that will represent the answer, or the problem itself, no, with this activity. You just simply use this guide for in dealing with this activity. Thanks for watching. So like, comment, and please do subscribe.